Hi, welcome to this session. In this session, we'll learn the charging and discharging of a capacitor. So we'll study the charging and discharging. Let's use Multisim to do this charging and discharging analysis of an RC circuit. So let's start with the basic RC circuit. As you can see, the RC circuit in your screen. Now we have a series RC circuit connected to a 1 volt source through S1, and there is another switch S2 here. Now S1 will connect the source VS to this RC circuit, and switch S2 will remove this source from this RC circuit. In other words, switch S1 will use for charging and switch S2 will use for discharging. Now, before we proceed in with the simulation of this circuit, let's first study the few important things about this RC circuit. We know in an RC circuit, capacitor charges exponentially, and this is the capacitor voltage at any given time in an RC circuit, where Vs is the source voltage, 1 minus e to the power minus t by tau. So capacitor charges exponentially, where tau is called the time constant of this circuit. So time constant for the circuit is R multiplied by C. R is 1, C is 1. So time constant for the circuit is 1 second. So first observation is that the capacitor charges exponentially. Now, capacitor charges as well as discharges exponentially. Here is the discharging equation, where V naught is the initial voltage stored in the capacitor. Now, second observation that we'll have is how much time it takes practically a capacitor to fully charge. Practically, it takes 5 time constants, means 5 tau. Time constant for circuit is RC. So tau for this circuit is 1. So practically the capacitor should, when we close this switch here, it should charge in 5 seconds. So this capacitor should take 5 seconds to fully charge to this source voltage. Similarly, the discharging time practically is 5 time constants. So when we close this S2, this capacitor should fully discharge in 5 seconds here, because tau for the circuit is 5 seconds. That's another observation of that. Now theoretically it will take infinite time, as we can see if we put t is equal to infinity here. So Vc at t equal to infinity will be equal to Vs, because this term will be equal to 0. So theoretically it takes infinite time, practically it only takes 5 time constants. For this circuit, that will be equal to 5 seconds. Okay, now both in charging and discharging. That's the first observation that we'll learn about this. Now, the most important observation about this charging and discharging will be that this charging is independent of the source voltage here. That means if we increase or decrease this source voltage here, the capacitor will still take 5 time constant. Time constant for the circuit is 1 second. So it will still take only 5 seconds to charge, no matter how much is the source voltage, 1 volt, 10 volt, 20 volt. That is the another observation that we'll learn today. Okay, so capacitor discharging and discharging is independent of the source voltage. Okay. Now, what is the charging current of this RC circuit? The charging current is given by Vs by R, where V is the source voltage, e to the power of minus t by tau. Now, if we put t equal to infinity here, at t equal to infinity, the capacitor voltage will drop to 0. Means when the capacitor is fully charged, the capacitor current should drop to 0. Now, at the time of switching, means when we close this switch, let's call that at t equal to 0. If the capacitor voltage is 0 at the time of switching, so at t equal to 0, if we put t equal to 0, the initial current flowing in the circuit is Vs by R. Now, if we look at the circuit at t equal to 0, if capacitor voltage is 0, means this will act as a short circuit. So the current flowing here will be simply Vs by R. So at t equal to 0, the capacitor current is Vs by at t equal to infinity, or after t equal to 5 time constant, capacitor current should drop to 0, as given by this equation. So when the capacitor fully charges, capacitor current will drop to 0, and at the time of switching, means when we close the switch S1, capacitor current is simply given by source voltage divided by the resistance. Okay, that's another observation. And at the time of switching, the capacitor current will reverse its polarity. What do I mean by this? When we open this switch and close this switch, well, because the capacitor is fully charged, now this will act as a source. So if the current was flowing like this for charging, now when we close this switch, because the capacitor will act as a source now, capacitor current will flow like this. So it will reverse its direction. So capacitor current reverses its direction at the time of switching. This is the case. Discharging case. Okay, so these are the observations that we'll study in multisim. Let's start with the first one, that is the capacitor charges and discharges exponentially. Let's switch to multisim now. So here is the circuit in multisim. Now we'll plot this on the output and input voltage as well, as you can see from the screen. That the green is the output voltage, is that it is not charged at any value, and red is the input voltage, as the input probe is here and the capacitor voltage probe is here. Okay, so let's first study the charging case. Let's close the switch S1. As you can see, capacitor voltage is rising exponentially. Let's see how much time it takes on this capacitor to fully charge. Okay, as you can see, now the this capacitor voltage has fully reached to this. As you can see, it almost started at 15. The charging started at 15 point something, and it fully reached to almost here. The source voltage, that is 20.9. So almost it takes 5 seconds to charge. As you can see, if you can see from the screen, the number of divisions: 1 division, 2 divisions, 3 divisions, 4 divisions, 5 division. Capacitor fully charges in this 5 division, and 1 division is equal to 1 second. So it takes 5 seconds to fully charge. That was the first order, that it takes practically capacitor 5 time constant, that is 5 seconds here to fully charge. It was the first observation. So let me continue discharging. This is, so capacitor is now fully charged. Now let's study the discharging case. Okay, so let me open this switch S1. Now as the capacitor is fully charged, now we'll close this here. You can see capacitor voltage is dropping exponentially, and practically how much time it will take? It will again take 5 seconds to fully discharge. Okay, as you can see, capacitor voltage is dropping exponentially. Okay, almost it has reached to that 0 here. We will see number of divisions, as you can see from here. Let me, the discharging started here, and it is fully charged almost here. So you can see 26 and 31 here. 31 minus 26 is almost 5 seconds. So almost in 5 seconds, it fully discharges. Okay, that was the first one. So first observation is capacitor charges and discharges exponentially. So let me continue the discharging. Also, it is now discharge. All right, so that's the first one. So now let's charge it again. Okay, as the capacitor is fully discharged here. Now you can see capacitor voltage is again rising exponentially. Okay, you can check from this, and you can count the number of divisions here to calculate the time, charging time. Similarly, we'll discharge it here. So you can see now it is discharging exponentially. That was the first thing. So first observation was it will charge and discharge exponentially, that we saw. And also it takes 5 time constant to fully charge and discharge. You can count, measure this time. You can put the cursor here. This will tell you the time. It is 40. Discharging started at 44.7, and it almost reached here. 49 point something, it reached to the 0. As you can see, 49 point something minus 44 point something is almost 5 seconds. So it takes 5 seconds to charge and discharge. That was the first observation. Now, another observation that we saw that the charging and discharging is independent of the source voltage. So if we change the source voltage, the capacitor charging and discharging should take only 5 time constants. 5 time constants is equal to 5 seconds here. So it should only take 5 seconds. So let me increase the source voltage to now 5 volts. Let me fully discharge it first. So capacitor is fully discharged. Now let's change it to 10 volts. To study that capacitor voltage is independent on discharging, and discharging is independent on source voltage. Okay, so let's connect this and let's, you can see. Okay, let me change the scale. You can see how much time it takes. You can see the charging almost started at 52 seconds and it reached almost to this here at 57 seconds because this is not fully charged. Let me turn it on a little bit more. Okay, you can see now at 57 seconds, the capacitor reached to the source voltage 10 volts. So again, it took only 5 seconds. So charging start almost at 52 seconds. That's 52 point something. And it reached to this 10 volt voltage and at 57 point something. So you can see again, it took only 5 seconds for this capacitor to charge. You can check here. It started, charging started at 52 point something and it reached to 10 volts at 57 point, okay, seconds. So again, the charging took only 5 seconds. Same is true for discharging. Okay, no matter how much voltage the capacitor is initially charged, it will only take 5 time constants to fully discharge this capacitor. So this is another observation. So capacitor charging and discharging is independent of source voltage. Okay, now let's study the discharging one. You can see capacitor is discharging exponentially again. But now the initial voltage stored in the capacitor is now 10 volts. So it will take how much time? 5 times. So okay, let me stop the simulation here. You can see the discharging started at 60.8 and it almost reached to 0 volts at 66 point something. Okay, so again, it took how much time? Almost 5 seconds to fully discharge this capacitor. Okay. So this was the charging and discharging. And second important observation was that the capacitor charging and discharging is independent of source voltage. So it only takes 5 time constants, no matter what is the source voltage. Okay, now let me increase it to 50 volts now. Let me change the source voltage to 50. Okay, let me scale it first because observers. Okay, I have changed the capacitor input voltage from 10 volts to 50 volts. Now our goal is to check how much time it takes for this capacitor now to charge to 50 volts. Let's see. Now you can see the capacitor should only take 5 seconds to charge to 50 volts. As you can see, it is rising towards 50 volts. Let's stop the simulation here and check the how much time it is. So the charging almost started at 82.2 seconds and it is fully charged almost at 87 point some seconds. Okay, as I cannot measure this accurately. This is 0.2 something and capacitor voltage reached to almost 87 point something. Yeah, so it almost takes only 5 seconds to fully charge. So charging is independent of the source voltage. Okay, it only depends upon R and C. Okay. All right. So let me show you the discharging case for this 50. You can see it will again take only 5 seconds to fully discharge. All right. Now let me fully discharge it and change the value of R to 2 seconds. Okay. Let me change it to 2 seconds. Sorry, R2 equal to 2 ohm and see how much time it takes now. So let me change R2 equal to 2 ohm. Okay, so now my new tau is 2 seconds because tau is equal to R times C. R is 2, so now time constant is 2 seconds. So how much time it should take this capacitor now to fully charge? 10 seconds because 5 tau is equal to 10 seconds. Tau is 2, so it should take how much time? 10 seconds now, this capacitor to fully charge. Let's observe that. Now it should charge in 10 seconds. Let's observe that. The charging is again the same. It is charging exponentially. The charging behavior is exponential. Capacitor charges exponential. Now, because my time constant is now 2 seconds, so it should take now 10 seconds to fully charge. Okay, let me stop it here. We will assume that it's almost reached to this. So it's here it started at 101 seconds and it reached it to here almost at 100 because it's not fully charged. It will take one more second to fully charge. Okay, let me stop it here. So it started at 101. You can see at 111, the capacitor is almost reached to 50. So it is dependent upon tau. The charging and discharging is dependent upon tau, not on the source voltage. All right, hope you understood this. So let me turn on the simulation again. It is fully charged. Now let's discharge it. Again, it will take 10 seconds to fully discharge this capacitor. Okay, you can see, you can observe it yourself. So discharging started at 112.7 something. Let's see how much time it takes to fully reach to 0. So discharging started at 112.7. And we'll assume it almost reached to 0 volts here. And you can see 123. Okay, almost it is reached to 0. It is reached to before that. You can see the capacitor voltage is almost to 0 here. So 122.6. So again, it took only 10 seconds. So 5 time constant is 10 seconds. So it took only 10 seconds to fully recharge. So that was the observation that capacitor charging and discharging is dependent upon the time constant. Now this circuit means R and C, but independent of the source voltage. Okay, now so this was charging, discharging, and how much time it takes the capacitor to charge. Now let's study the behavior of current. Okay, so let me change the resistance value back to 1 ohm, and let me bring a current probe now. Let's observe the capacitor current as well. So this is my current probe. Okay, let me change the width of this probe and change. Let me scale it. So this is the charging and discharging that we studied here. So let's observe the and this current as well. Okay, turn it on. Now current is shown on the right hand side. The current axis is on the right hand side. You can see. Okay, so let's start with this. Okay, as you can see, current is it is showing it as 50 microampere. Let me make it to 0 first. Let's make current equal because there was some voltage initially stored in the capacitor. So let's make it 0 first. Like, as you can see, the current axis is on this side. The current axis is on this side. Now it is 0. Current is 0 as this is fully discharged now. So the capacitor is fully discharged. It's actually not fully discharged, but there is some error that is due to switching because we don't have ideal switches in Multisim. Okay, there's some little error, but that's due to. Okay, let's observe the charging and discharge. And let's observe this. What is the initial current flowing? The initial current here should be 50. As I close the switch S1, 50 divided by 1, that is 50 amperes. So initially, when I close the switch, the current that should flow in the capacitor should be equal to 50 amperes. Okay, you can see as the capacitor voltage is rising. Now to see the current as well, let me change the current axis. You can see, let me stop it here. Capacitor is fully charged. Okay. Now you can see here I close the switch. The capacitor current shot up to 50 amperes. You can see at the time of switching, you can see current axis is on this side. Initial current flowing in the capacitor is 50 amperes. Here you can see from this right hand side axis. Now when the capacitor voltage reaches to 50 volts, capacitor current almost drops to zero. You can see from this, I continue this, you can see capacitor current drops to zero. Okay, so as the capacitor charges, the capacitor current drops to zero exponentially. Yeah. When it is fully charged, capacitor current will drop to zero, as you can see from the right hand side axis here. Current is measured on this side, voltage is measured on this side. So this pink one is the current, green one is the voltage, and red is the source voltage, or the source connected to this RC circuit. So now our capacitor is fully charged to 50 volts and capacitor current has dropped to zero. Now, as I disconnected this switch, capacitor current is zero. Now, if I close this switch, you'll see one interesting behavior here, that the capacitor current reverses its polarity. As you can see, let me change the scale again to show you the effect. As you can see now, capacitor current is reversed. Capacitor current is now minus. At the time of switching, initially it will be minus 50 amperes, and it will continue decreasing because capacitor voltage is decreasing. Okay. All right, as you can see now, capacitor current is approaching to zero. But the interesting point here is that at the time of switching, capacitor current reversed its direction. Why is that? Because in the discharging circuit, we have R, C, and switch. So now source, capacitor is acting as a source. So at the time of switching, means when we connect to this S2, current will now flow like this, because this is the positive terminal of this capacitor. As capacitor voltage cannot change, so capacitor current reverses its polarity. In a source, the current always comes out of the positive terminal. So current will flow like this. That is why the current has to reverse its direction, because capacitor is acting as source now. And in a source, current always comes out of the positive terminal. Okay. Okay, you can see from this. That's another observation, that current reverses its direction. Now I'm going to open this and study this again. You can see the charging case. Initially, the capacitor current is 50 amperes, that is 50 divided by 1, that is 50 amperes. And as the time progresses, that is in 5 time constants, capacitor current will fully drop to zero and capacitor voltage will fully reach to the source voltage. That's the observation. Okay. Now, if I disconnect this, as the capacitor is fully charged and capacitor current has fully dropped to zero. Now, if I close this discharging switch, that is S2, now you can see capacitor current reverses its polarity. Capacitor current reverses its direction. Okay, you can see at the time of switching, capacitor current reverses its. These are some of the observations. Okay, so what we studied here. The first observation was that capacitor charges exponentially, both charges as well as discharge exponentially. And it practically takes only 5 time constants for this capacitor to fully charge and discharge. And charging and discharging is independent of the source, but it depends only upon the time constant of this circuit. Another observation is that at the time of switching, means when we want to discharge this capacitor, the capacitor current reverses its direction. Okay. All right. So let me stop it here.